Hello 3D printing friends! Today on the BV3D channel we'll see how to install the E3D Revo Micro on the Ender-3 V2. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're going to get a look at the new E3D Revo Micro hot end and get it installed on an Ender-3 V2. But in order to install it, there are a few things that need to be done first. It'll be necessary to print a new mounting bracket and a fan duct. The files for this are available from E3D, and it's recommended to print them with a material such as PETG or ABS for heat resistance. It'll also be necessary to edit and compile the firmware to change the thermistor type and to increase the maximum allowed hot end temperature. The firmware thing may sound like a huge issue, but it's really not. I'll be using the JyersUI fork of the Marlin firmware, and I've already got a video showing how to edit and compile and install it, so you can refer back to that one for the full how-to. And there's a link in the description. Once the firmware has been updated on the printer, we can go about the business of removing the old hot end and wiring in the new one. To make things easier for you, this video is divided into chapters, so use the chapter markers down in the video's timeline to jump around, skip over things, or come back to things later. Before we start installing the Revo Micro, let's take a quick look at it. E3D was super kind and reached out to me right before Christmas and asked if I wanted to get a look at this new product, and of course, I said yes. So E3D sent the basic Revo Micro kit to me at no charge, and that's the kit with a single 0.4mm nozzle on board. Now there was a bit of a shipping delay because I messed up entering my address on their website. You'd think I'd know my own address by now, right? Well, anyway, a huge thanks to E3D for sending this my way. Now it comes very nicely packaged in this small cardboard box. On the top, there's the Revo Micro hot end with a cooling fan and a 0.4mm nozzle already installed. There's also a space for the other 3 nozzle sizes E3D makes for it, so if you get the kit with all 4 nozzle sizes, that's where you'll find them. Underneath this, there are the connecting wires needed to get the hot end hooked up to the printer. The cooling fan on the heatsink is a 5-volt fan, and its connecting wires include a very slim inline voltage converter to take the 24 volts for the stock fan down to the 5 volts required for the Revo Micro's fan. Now, this is the only component in the kit that's polarized, so later when getting all this wired into the printer, it will be very important to keep the polarity correct. Positive to positive, negative to negative. Otherwise, the magic smoke might escape from that converter, and then it won't work. So the flagship feature of the E3D Revo series is the ability to very quickly and easily cold swap the nozzles. This is super handy if you want to switch from a standard 0.4mm nozzle to a nice fat 0.8mm nozzle. Or just swap out one nozzle for another of the same size if you get a clog or a jam to get back up and running quickly. Now that's because the nozzle isn't just the nozzle part that goes into the heater block, it's also the part that goes up into the heatsink. As E3D puts it, Revo nozzles are a factory-sealed nozzle and heat break in one, so they're easy to fit and can't leak material when in use. The Revo products also have this new super compact cylindrical heater core, which also includes the thermistor. It's all one piece with a nice silicone sock around it. And it has a strain relief built in for the wires where they come out of the heater core to help protect them from flexing too much and breaking. The Revo Micro can be used in Bowden setups like we're going to do today and in direct drive setups. However, because the Revo Micro is such a new product right now, the only mounting solutions I see from E3D are for certain Creality printers and for the Prusa Mini. I think once the Revo units start showing up in the wild, you'll start to see people making printable mounts for other printers too. So speaking of printable mounts, the first thing we need to do is download the files from E3D that let us mount the Micro to the Ender-3 V2. 2 of the files in that download are a fan duct, one with built-in supports and one without. But there's a slight problem with the fan duct when it comes to the Ender-3 V2. See, the Ender-3 V2 has a different fan shroud from the older Ender-3 models, so the hole pattern on the X carriage is a little bit different. The fan duct from E3D is designed for the screw hole pattern on the X carriage of the older printers. On the Ender-3 V2, the bottom screw hole is in the right place for the E3D fan duct, but the top hole is 4mm higher up and 3mm to the left from where it would be on the older Ender-3 printers. And that hole isn't threaded. It's designed for the screw to pass through. The screw goes through it from the back of the X carriage and into the Ender-3 V2's fan shroud to hold it in place. So rather than using just one screw on the bottom of E3D's printable fan duct and hoping for the best, I decided it would be better if I simply remixed the part by adding a small hole where it was needed and making the new model available for download. That way everyone with an Ender-3 V2 who wants to upgrade to the Revo Micro would be able to install the fan duct with 2 screws. So download the files from E3D so you get the Revo Micro mount, and then download the files from the link in the description to get the fan duct that has the holes in the right place for the Ender-3 V2. And then of course, slice them and print them. After all, it's a lot easier to print the things you need for mounting a new hot end before you take the old hot end off the printer, right? Now, E3D has recommendations for print settings: 4 perimeters, 5 top and bottom layers, 40% infill. Unspecified but assumed is a layer height of 0.2 millimeters. I printed the Revo Micro mount and the modified fan duct in Polymaker's red PETG at 240 degrees Celsius, and they came out great. Total print time was about 3.5 hours. So with the parts printed, let's turn to the firmware. I'm going to be using the default JyersUI configuration for this because the Ender-3 V2 I'm installing this on is just a stock machine. After we get the modifications made to the firmware, we'll compile it and install it on the printer. I'm going on the assumption that you've got the Visual Studio Code environment already set up, you've downloaded the latest JyersUI source code from the Releases section of the JyersUI GitHub, and you've put the default no probe configuration files into the right place in the source code files. Now, if what I just said makes absolutely no sense, then after you're done watching this video, please go watch my Edit and Compile JyersUI firmware for the Ender-3 V2 video. It covers the entire process. Keep watching this video though to see what we're going to change in the firmware and to see what's involved in getting the Revo Micro installed. Then if you decide that the Revo Micro is definitely something you want to have, that other video will help you get to the point where you can make the changes to the firmware source code. So the changes we're going to make are really quite simple. The thermistor E3D uses on the Revo Micro is different from the one on the stock Creality hot end, so we need to change where that's configured in the source code. The type of thermistor is defined on the identifier temp sensor 0. So click the Edit menu, then click Find to get to the Find field. Inside, type temp_sensor_0, and that line will be highlighted in the code. See how it's defined with the value of 1? Change that 1 to a 5. Next, E3D recommends making sure the minimum nozzle heater temperature is set to 5 degrees Celsius. This is defined as heater 0 min temp. So do a find for heater_0_ min temp, and that line will be highlighted in the code. Here it's set to 0, so change that to 5. The next thing to change is the heater 0 max temp value. The stock Ender-3 V2 firmware, as well as JyersUI, cap the maximum temperature of the nozzle heater at 275 degrees Celsius. And in reality, there's a hot end overshoot limit of 15 degrees Celsius, which gets subtracted from the max temp value. So the actual maximum value you can set for the hot end is 260 degrees Celsius. The Revo heater core module on the Revo Micro is rated for a maximum temperature of 300 degrees Celsius. So if you want to gain a little bit of extra nozzle temperature, we can adjust that max temp value to 300. Minus the overshoot value, that will allow you to set the nozzle temp on the Revo Micro up to 285 degrees Celsius. So in the Find field, type heater_0_ temp, and that line in the code will be highlighted. Change the value from 275 to 300. The last edit, and this is purely for fun, is to change the name of the printer that gets displayed on the screen. Now you don't have to do this, but if you want to, here's how. The printer's name is defined with the custom machine name identifier. So in the search field, type custom_machine_name to highlight that line in the code. It's currently set to Ender-3 V2, and I want to add to it. I'll add plus Revo Micro, so now it'll say Ender-3 V2 plus Revo Micro on the screen. Okay, those are all the changes we need to make. Click File and then Save to save this file. Then click the checkmark icon down on the blue ribbon at the bottom of the window to compile the firmware into a binary file for the printer. Once the compilation is finished, the output shows where it was stored, and it's down inside the .pio folder. Right-click on the firmware file that ends with .bin and select Reveal to show the folder it's in. Copy that firmware file to a micro SD card that's been properly formatted. Turn the printer off, insert the card, and turn the printer on again. If all goes well, the printer will apply the firmware update. About 5 or 10 seconds after turning the printer on, the screen should show the normal boot process with the progress bar. You can confirm that it's been updated by going to the Info menu. It should indicate it's running a version of Jyers. It should also show the custom name at the top of the status area down at the bottom of the screen. Now sometimes another status message shows up there, like when you remove the card from the printer and it says media removed. So anyway, that takes care of the firmware part of the upgrade. Okay, with the firmware upgraded, it's time to remove the old hot end and install the printed parts in preparation for installing the Revo Micro. To start, make sure the filament is unloaded so there's none in the printer at all. Also, make sure the printer is turned off, unplugged, and all the hot parts have cooled to room temperature. Let's start by taking the old hot end off. Cut away the zip ties along the cable sleeve. These are the ones securing it down at the hot end as well as keeping it secured to the Bowden tube. Remove the fan shroud. There's one screw on the back that secures it to the X carriage. Remove that screw and then you can angle it to the side a bit and then lift it away. It's okay that the wires are all still attached. Just be careful with them so you don't break any of them. Then remove the PTFE tube from the stock hot end. Now, sometimes this is more easily said than done, and in the past, I've had to turn the printer on, heat the nozzle up to about 200 degrees, use the wrench that came with the printer to unscrew the fitting at the top of the hot end and pull hard to get the Bowden tube out of the printer. Then I could get the fitting off the Bowden tube, and of course, turn the printer off and wait for it to cool down. But for the purposes of this video, I'm showing the ideal scenario here, which is this. Remove the collet clip, and then press down on the retaining ring and lift the tube up and out of the hot end. Then remove the stock hot end. It's secured with 2 screws. And again, it's okay that the wires are all still attached. Just continue to be careful not to damage them. The cable bundle and all the parts can just rest on the bed for now. To attach the Revo Micro mount to the X carriage, we're going to use the screw that held the fan shroud there originally. And we're going to have to harvest some of the screws from the original fan shroud too. Let's pull this one off. Okay, now we have 2 screws we can use to secure the Revo Micro mount. The mount fits over the 2 posts where the original hot end was. It should just slide onto them. Then, using the 2 screws we got from the old fan shroud, secure the new mount onto the X carriage. Next, harvest this screw from the old fan shroud. Use this screw to attach the bottom of the new fan duct to the X carriage. Now, E3D did a great job of designing things to reuse hardware that gets removed from the Ender-3 for this upgrade. But we just need one more screw than we have available. So you're going to have to find another M3 screw somewhere so that you can attach the top of the new fan duct. An M3x6 is ideal for this. This screw comes in from the back of the X carriage and it cuts its own threads into the fan duct to hold it in place. Now that the printed parts are in place, it's time to get the Revo Micro mounted. Unscrew the nut from the top of the Revo Micro. We're not going to use it for this installation, but keep it handy in case you decide to use another mount that does require it. Unsnap the heatsink fan shroud from the front of the Micro. Remove the nozzle from the hot end and set it aside for now. Then remove the heater core from its spring. Now we've got just the heatsink part, and this gets screwed into the printed mount. Tightening this by hand should be sufficient. Now that the heatsink is mounted, reattach the heater core to its spring. Then screw the nozzle back in. Snap the fan shroud back onto the heatsink. And then remove the collet clip, connect the Bowden tube to the top of the Revo Micro, and put the collet clip back on to keep the retaining ring in place. Now mine is red because I apparently lost the one that came with the kit, so I printed another one. Oops. Oh, and another note. How you want to route the wires from the heater core is up to you. I installed the Micro with the wires coming out the front, but then I thought maybe I could get the wires to go between the 2 output bits of the duct, and that wasn't super satisfactory, so I decided to have the wires toward the back, coming up between the fan duct and the Micro's mount. Okay, that's it for getting the Revo Micro mounted. Now it's time to get this thing wired up. Remove the stock parts cooling blower from the original fan shroud. Also, remove the ductwork that's attached to it. There are 2 screws holding it on. Then, making sure the fan's wires go over the top of the x-axis and not under it, attach the blower to the duct. It can be a bit of a tight fit. In my case, it's quite snug, but if it's a bit loose on yours, you can use one of the screws you just removed from the original ductwork to attach it to this one. Next, we're going to have to get into the electronics bay on the printer because we need to disconnect the original nozzle heater cartridge, thermistor, and hot end fan and remove those wires from the cable sleeve. There is a screw on top here, and then 3 screws on the bottom holding the lower cover on. The screw at the rear of the electronics bay is longer than the other 3. You'll need to remember that when putting the cover back on. Also, when removing the cover, note that it has a cooling fan on it that's connected to the main board, so be careful of its wires. If the wires are bundled up with a zip tie, cut that zip tie so you can get to the individual wires. Using a standard screwdriver, loosen the clamping screws on the terminal block here to release the heater cartridge wires. Unplug the thermistor. It's plugged into the 2-pin socket closest to the front of the printer. And then again with the screwdriver, loosen the clamping screws on the terminal block here to release the wires for the hot end fan. Pay special attention to the position of the red and black wires here. They indicate the polarity. Red indicates positive and black indicates negative. This will be important in a few minutes when installing the voltage converter for the Revo Micro's hot end fan. Remove any other zip ties on the cable sleeve all the way from the electronics bay to the hot end. With those zip ties removed, we can pull the old wires out and then put the new wires in. It's not too difficult, but the wires may occasionally snag on the cable sleeve, so be patient. Work carefully and you'll get through it. When you're done, the only wires left in the cable sleeve at the hot end will be the ones for the parts cooling blower. When it comes to getting the Revo Micro's wires back into the cable sleeve, don't do what I did. Don't try to push the wires into the sleeve. You might be able to get one set of them through, but after that it's going to be tough. Pushing wires through a cable sleeve is like trying to push a chain. What I should have done is attach a pull string or a spare wire to the end of one of those wires that I was pulling out, so I'd have something that I could pull the new wires in. So I managed to get the heater core's power wires into the cable sleeve by sheer dumb luck pushing them through. It was a lot harder to get the heater core's thermistor wires through, but when I finally got them, I attached a spare wire to them with some tape and pulled the thermistor wire back out, which pulled the spare wire into the cable sleeve, and then I used more tape and attached the Revo Micro's fan power wires to the spare wire and pulled that through to the electronics bay. What a mess I made for myself. Sometimes I'm about as smart as a bag of hammers. So again, do this the easy way. Pull a spare wire or a string through the cable sleeve by attaching it to the old wires when you're pulling them out, and then use that spare wire or string to pull the new wires in. Whew. Okay, so put the heater core's power wires into the terminal block here and tighten the clamping screws. Put the thermistor wires connectors into the socket here. Now, when it comes to the fan wires, remember that the fan is a 5-volt fan, and the main board here is designed for a 24-volt fan. So E3D provides a voltage converter to turn the 24 volts into 5 volts. But the connector on the 24-volt side of it is designed for a more civilized main board that has the same kind of connector as the thermistor, just a simple 2-pin thing. Unfortunately, the Ender-3 V2 is powering the fan from that terminal block. So it'll be necessary to snip that connector off the end of the wire on the input side of the voltage converter. Then strip some insulation off of the end of the wires. To avoid the risk of shorting the 24-volt supply to another component that might not appreciate it, I'm putting some ferrules on the ends of the wires to keep the strands together. You could also tin these with solder. Now, this is a low current application, so tinning the wires here won't lead to problems like it could with the high current wiring. But I have the huge $25 assortment with the crimper and the ferrules for every occasion, so I don't have to wait for a soldering iron to heat up. Okay, now to get this voltage converter connected. The positive red wire goes here. There's even a little plus sign to indicate it. And the black wire goes here. So get those connected in. Now on the other end of the voltage converter, there are 2 pins. Here too, the pins are marked with a plus for the positive side and a minus for the negative side. Plug the hot ends fan cable, that's the black and red one, onto these pins. Make sure the red wire goes on the plus and the black wire goes on the minus. Back at the hot end side of things, plug the hot ends connectors into their wires. The heater core power cable is this one, white with red stripes, and it goes into the connector with the two black wires. The heater core thermistor cable is this other one. It plugs into the connector with the two white wires with the blue stripes. Finally, the hot end fans cable is this one, and it plugs into the connector with the black and red wires. At this point, it would be a really good idea to plug the printer into power, turn it on, and verify that the hot end fan is running and the screen is displaying a hot end temperature about the same as the bed. Then, go into Control, Temperature, Hot End to set the hot end temperature to something like 100 degrees Celsius, just to see if the heater core is getting power. And then set it to cool down as soon as you see the hot end temperature rising. Finally, verify that the parts cooling fan works by going to Control, Temperature, Fan, and setting it to 255. If any of these things don't work, double check your wiring. In particular, it can be easy for the thermistor's wires to pull out of the connector on the main board since it's not using the same kind of plug that the original did. When you're sure everything is working, turn off the printer, unplug it, and then neaten up the wiring inside the electronics bay. Zip ties are your friend here. Close up the electronics bay with the 4 screws that you removed from it. Remember that the longer of the 4 screws goes toward the back. Then reapply zip ties along the cable sleeve where necessary to get it back the way it was before we started this installation, more or less. One thing I noticed while doing this is that the wires E3D provides are shorter than the originals. If you route the cable sleeve from the electronics bay out toward the back of the printer the way it was before this installation, there won't be enough slack in the cables that go to the hot end. But by bringing the cable sleeve out to the side of the printer from the electronics bay, I had enough slack in the cable to make this work. And don't forget to tidy up the wires at the hot end side where they go into the cable sleeve. This may be a little easier said than done since the connectors are somewhat bulky and they kind of cluster together. Okay, so once the printer's all back together, the very first thing to do is run a PID tune on the hot end. Now with JyersUI firmware installed, that's super easy. Click into Control, Temperature, PID, Hot End. Set the temperature to what you most frequently print at. I'll set this to 220 degrees Celsius. Then click Auto Tune. A message appears on the screen to let you know it's doing its thing, and once that message goes away, you're done. Head back to Control and then Store Settings to save the new PID values. Now once the PID tuning is done, it's time to level or tram the bed. We did, after all, replace the entire hot end, so this is a must. JyersUI has a nice manual leveling assistant that lets you move the nozzle to each corner of the bed and to the center to get it adjusted. Oh, I remembered from when I installed a Micro Swiss all-metal hot end on an Ender-3 that I needed less retraction, and the same seems true with the Revo Micro. I was able to reduce my retraction value from 5 millimeters down to 2.5 millimeters at a speed of 30 millimeters per second, so you may want to experiment with your retraction values too. So we're just about done with this video. And what have I learned from this installation? Well, I was reminded that installing a new hot end with new heater and thermistor and fan wires is always going to be an activity that is firmly within the realm of DIY projects, and no general purpose kit can anticipate every need or every existing modification people have made to their printers. So I get why the extension wires on this kit are the length they are. It's general purpose, and I get the feeling that the wire length was based on the original Ender-3, which has its hot end wiring routed differently from the Ender-3 V2. I like having connectors close to the hot end for ease of maintenance in the event that you need to replace a component, but the trade-off is that you have a lot of connectors close to the hot end, so from an aesthetics perspective, I'm not super happy with how this looks. I'm going to have to think about what I can do to make it nicer. I'm actually thinking this would look a lot better if I didn't have these connectors all bunched up here. Maybe I can just cut these connectors off and splice in some longer wires? And that would get rid of the connectors and let me reroute the cable sleeves back to their factory positions. For the fan and thermistor wires, I think doing a cut, strip, solder, and heat shrink splice is acceptable. But what about the heater core? What's the best way to extend heater wires? A soldered splice? Crimp-on butt connectors? Let me know what you think down in the comments. The other thing that makes this very much a DIY project is making changes to the printer's firmware. Now, it's not overly complicated. just changing a few numbers here and there, compiling and then installing the firmware on the printer. But some people just aren't comfortable doing that, and other people aren't comfortable messing with their printer's wiring. And that's okay. That's okay. I used to be deathly afraid of blowing up my printer by messing with the electrical and electronic parts. It took me about a year before I felt comfortable enough to start trying to do mods and upgrades that were more than just printed parts. Let's see, what else did I learn? Oh, I learned not to try pushing wires through cable sleeves. That was just dumb. Okay, so I feel like this has been kind of a long video about something that in principle sounds simple. I mean, really, what all did we do? We printed a couple of parts, we did a firmware upgrade, we removed the existing hot end and installed a new one. I just wanted to give enough detail so you'd know what you're really looking at in order to install this. So I'm sorry if it's longer than usual, but it needed to be. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end. And thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great. And if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BB3D channel.